We will finish off by simply comparing SN1 reactions and SN2 reactions using various different criteria and seeing how these things stack up. So first, when we talk about nucleophile, in SN1 reactions, nucleophile is pretty much irrelevant. Weak ones work too. In SN2 reaction, strong nucleophiles are needed, such as I-, cyanide, ethoxide, thiols, and so on. In terms of a substrate, SN2 reactions work best on tertiary substrates, worse than on secondary, virtually don't work on methyl, and work very weakly on primary substrates. SN2 is exactly the opposite. They work best on methyl, slightly worse on primary, significantly worse on secondary, and not at all pretty much on tertiary substrates. Solvents are different as well. SN1 reactions require polar protic solvents, such as water or alcohols. SN2 reactions require polar aprotic solvents, such as acetonitrile, DMF, DMSO, or so forth. Both SN1 and SN2 reaction require a good leaving group because both need the leaving group to leave in the rate determining step of the reaction. And so, good one needed for both SN1 and SN2. This is a point of similarity. In terms of their outcome, stereochemically, SN1 reaction gives us racemization. SN2 reaction gives us inversion of a configuration, which makes SN2 reaction synthetically more interesting since our stereochemistry is controlled. Kinetically, SN1 reaction is proportional, the rate of SN1 reaction is proportional only to the concentration of substrate, while in the SN2 reaction the rate depends both on the concentration of substrate and the concentration of nucleophile. And finally, rearrangements are common in SN1 reactions. They give stable cations, and virtually impossible in SN2 reactions. With this comparison, we will finish today's lecture, and next time we will start talking about eliminations, which is another broad class of reaction that is broadly applicable to halogenated alkanes. And we'll see how these two reactions that we discussed so far and further two reaction mechanisms we'll discuss next week combine to give a very complex picture of reactivity of halogenated alkanes.